today's virtual career exploration video. I'm Danielle Britton, Talent and Education Director for the Greater Binghamton Chamber of Commerce and the Greater Binghamton Education Outreach Program. Today I'm joined by Brian Haas, who is an engineer at Delta Engineers, Architects, and Land Surveyors. Thanks for joining me today, Brian.
No problem, Danielle. Thanks for having me.
So we're going to jump right in. If you could just start telling us a little bit about yourself and a little bit about Delta.
Okay, so I'm an engineer at Delta Engineers. I'm in our transportation group, primarily working with bridges and construction engineering. My background is I'm a civil engineer, and I concentrate more towards structural engineering as well as civil site work design.
Awesome. So what made you interested in becoming an engineer, specifically civil engineering?
From a young age, I was always interested in building things, Legos, Connects, all of that stuff, figuring out how things worked. When I was 6 years old, my dad built a deck off the back of their house. And that's when I started to get introduced into tools, how things were put together, construction, stuff like that. So from a young age, I really had an interest in it. Always liked construction, specifically heavy civil construction. Wanted to get involved in that some way. I was always good at math and science and creative as well. So it was just a good path for me to take, and it's worked out well for me.
Awesome. What does a normal day look like for you in the world of civil engineering?
So we do both design and construction support. So mostly through the winter and fall, we're doing a lot of design work in office. We'll go out to the field and inspect bridges as we need to, take measurements, field notes, pictures, all that types of stuff, different types of investigation, so that we have what we need to put together a good design, whether it's a bridge rehabilitation or a bridge replacement project, culverts, everything. So we get what we need in the field and we take it back to the office. Office work includes a lot of design, meetings with clients, meetings with team members, drafting on the computer, different types of software to design beams, footings, foundations, bridge decks, and putting together the plans and specifications so that the owner, which is usually like the Department of Public Works or Division of Engineering at a local level with the counties or the New York State DOT, places like that, they can put the project out to bid. To receive bids from contractors so that they can get the project rolling and get the project actually built. So we're putting together all the contract plans and documents, everything from detour plans, demolition plans, foundation plans, and the bridge superstructure. And then once the bids come in, we have to review those and recommend which contractor satisfies all the requirements of the contract to actually build the project. So that's a lot of the in-office work. Field work, especially during spring and summer, we're out on site constantly, making sure the project's getting built right, assisting the contractor with any questions that they may have in the field, dealing with issues that arise, stuff that's underground that we may not have foreseen when we were out there doing our field work, or the survey didn't pick it up, something like that, or there's a mishap on the site that needs to be adjusted in the design. We take care of that. So field work is fun. A lot of times we have to put on our chest waders and walk through the water, whether it's a river or stream, throw the ladders and climb up on top of the piers, take different types of measurements, check the thickness of the steel. A lot of old bridges have a lot of section loss in the steel, so we have to measure that with different types of meters. So it's a good variety, a good mix of in-office and out on site types of field work. So it's good.
How far do you typically have to travel for your projects?
We do most of our work in upstate New York. So as far north as St. Lawrence County, we have a lot of projects going on up there. And as far as downstate we get is typically Sullivan County. But a lot of work with Otsego County, Oneida County, Ithaca area, and Broome County as well.
Awesome. Do sometimes those require like overnight trips, or are you typically there and back in a day?
Typically it's within a day. The farthest we have to drive is 4 hours, and that's not typical. That's a project at the far
Yeah.
reach of St. Lawrence County. So normally we'll drive 2 hours if we need to or so, spend the day out on site and then drive back.
Mhm.
But we have construction inspectors that we hire that are out on site every day while the project's getting built. So they kind of monitor and oversee the project while we can't be there.
Mhm.
So we're only on site maybe once in a while during
Mhm.
construction and pre-construction, as well as post-construction to inspect the final bridge.
Awesome. So you talked a lot about what you specifically do, but what other sorts of positions are available at Delta?
So we have a facilities group, a transportation group, environmental group, and a structural specialty precast group. So the facilities group consists of architecture, structural, mechanical, electrical, plumbing, um, landscape architecture, and civil engineering. So all those disciplines kind of fall into the facilities group, dealing mainly with buildings.
Mhm.
The environmental group does lead and asbestos testing, PCBs, stuff like that. They're out on site constantly with contractors doing air sample monitoring, making sure that the different environmental aspects are being taken care of so that it's safe for both the workers and for the site. Um, our specialty precast group does work in 49 out of the 50 states.
Wow.
They do a lot of everything precast concrete. So four-sided box culverts, three-sided bridge span units, manholes, different types of pipes and tunnels, as well as precast concrete buildings. So that's a lot of in-office work,
Mhm.
and they're dealing with contractors and clients all across the country. Um, and then what else? Our transportation group, we do civil highway work as well as bridge work, and a lot of construction engineering as well. Construction engineering, we work with a lot of local contractors as well as national contractors to put together bridge demolition plans, culvert or steel beam erection plans, stuff like that. Anything that has to be provided to the engineer of record for review and approval. So that contains all of the what crane they're going to use, where to place the crane, what types of pick radiuses they can use, different factors of safety, and all of the crane rigging that goes along with it. So there's a lot of different things that we do at Delta.
Wow, I had no idea. So what do you look for when you're, I know you mentioned you talked to a lot of students at career fairs.
Mhm.
And what sort of things does the company look for when they're hiring somebody?
Yeah, so I'm not in a
Skills
role
or,
to hire people.
Mhm.
That's typically up to the group directors. But what I
Mhm.
do is I go to a lot of college career fairs as well as high school career fairs.
Mhm.
And I also talk to high school students either at the school or in the office one-on-one, or go to like SUNY Broome and talk to one of their intro
Mhm.
to engineering type classes. And what we typically look for is somebody who's motivated, somebody
Mhm.
that's going to come in. They have their school background, their education. They know a little bit about what they're doing, but they're willing to learn exactly what we do and how we do it, because we can't possibly learn everything in school. So you have to have an open mind and willing to learn everything on the job uh, while also working with a team. Communication skills is a big thing. Being able to work with another person or a whole group of people. Again, the transportation group, we're only working with smaller groups, 2 or 3 people usually. But on the facility sides, where they have all the different disciplines of a building, you may be working with 12 to 15 different team members,
Mhm.
and you have to be able to coordinate your work with all of them, coordinate schedules, be on time. So communication and motivation are really 2 of the biggest things, as well as just a general understanding of engineering as well,
Mhm.
whether it's the civil discipline, mechanical discipline. Being able to understand other types of engineering is going to really plan out well for you when you're working in those types of team environments.
So do you have any suggestions on something maybe high school students and college students could do while in school to work on? I mean, obviously there's the engineering set of skills and courses to take,
Mhm.
but the other kind of professional skills that they could like participate in some clubs after school, like any suggestions on how to build those skills out?
Yeah, absolutely. What I tell all the students I talk to is just get involved uh, with clubs, with groups, with projects of your own. Whether it's building a deck at home, working with getting a job with a local builder or contractor, internships with engineering firms or construction firms, uh, clubs at school. When I was in college, I joined. We had what was called a speed team. I forget exactly what the acronym stands for, but it's applying everything we learn in class to an actual project. The project I was working on was called Steel Bridge, and so we would spend the fall semester designing a bridge that would meet the project specifications, typically about 20, 22 feet long and 3 or 4 feet wide, and it would have to carry 2,500 pounds. We were judged based on aesthetics, how much weight the bridge could carry before it collapsed, if it could carry all of the weight, how much it would deflect, uh, as well as time it took to build the bridge and actually put it together. There was a whole competition associated with it, but it really was like a small scale version of an actual construction project where we had design work, planning and manufacturing, as well as building. And everything associated with time, weight of material, how much it deflected, that's all gets associated with cost. The lighter the bridge weighs, the less material you use. The less material you use, the lower the bridge cost is. And the faster you can build it, the less labor cost is. So it's just a small scale thing that was all completely extracurricular. It wasn't required by any class, but things like that really prepare you well for working with the team, seeing how things develop from paper to an actual product. And there's a lot of different clubs and activities like that for all types of engineering. Chemical engineers have cars that they develop with different types of chemical reactions that power them. Mechanical engineering students can get involved with, they have mini Baja where they actually build a race car, or not a race car, an off-road 4x4 car, but they also have mini Indy car where they build a race car to compete against other colleges with. And then at the high school level, there's different engineering clubs that you can get involved with at your school where you may be building popsicle stick bridges or something like that. Anything that really gets your mind thinking creatively and outside the box, to take something from paper and from an idea and actually build something that's going to work. And so that's what I recommend to every student I talk to is just get involved.
Mhm.
Don't just go to class and do the minimum work to get a passing grade. Do something outside of class with extracurricular activities that you can put on a resume and actually talk about in a job interview and apply yourself, from those small scale projects to a large scale actual engineering project.
Awesome. And so typically to get into engineering, you need at least a 2-year degree, correct?
Um, a lot of our technical degrees or technical positions, such as drafters or construction inspectors, those types of positions only require only about an associate's degree
Mhm.
in either civil engineering technology or in engineering science. Um, but to get to a design level, you really need a 4-year bachelor's degree. So what I did was, after high school, I went to SUNY Broome for 2 years. I got an associate's degree in engineering science. Engineering science is pretty much the same first 2 years of any engineering curriculum you would go to at any 4-year school. And then after that, I was applying to different schools and ultimately decided on Clarkson University up in Potsdam, New York, where I pursued a 4-year degree in civil engineering with professional concentrations in structural engineering and construction engineering management. Now, those uh, professional concentrations, they're not necessary. It's kind of like a minor, but to get to a design role, definitely a 4-year degree, a bachelor's of science. And then there are students that move on to pursue a master's degree, but for me, pursuing a professional license was more important than pursuing a master's degree. So in order to get a professional license, which is pretty critical in civil engineering specifically, anything structural related, you have to be able to stamp your drawings to prove competency and due diligence. So in order to get that, you have to pass the FE exam, which is the fundamentals of engineering. and that exam tests you on everything you've learned over your 4 years of college. There's two parts. The first exam is first and second year, your freshman and sophomore year of college. So you have chemistry, biology, environmental stuff, calculus, those types of classes. And then the second part of the exam is everything related to your discipline. So me being civil engineering, I was taking, or I was being tested on subjects like steel design, reinforced concrete design, water resources, surveying, structural analysis, stuff like that. So that gives you your EIT, which is an engineer in training. And then once you receive the EIT, you have to obtain 4 years of professional experience in order to be eligible for the professional engineer's exam. And actually this past Saturday, May 9th, was my 4-year anniversary with Delta. So as of June 1st, when applications open, I'm officially eligible to apply for the PE exam. And that exam is offered twice a year in April and October. So hopefully be able to sit for the October exam. And then if you want to go even further than that with the structural discipline, there's an SE license, which is a structural engineering license. It basically proves your competency in structural engineering, as the name suggests. But definitely going back to the education requirements, bachelor's degree is pretty, I'd say, recommended. You can get to different types of levels with a lower degree, with an associate's degree, but it's going to take you longer.
And more growth opportunities with a bachelor's degree, for sure.
Absolutely, yep.
Awesome. Is there any additional advice that we missed that you might give somebody looking to become an engineer or generally working?
Just going back to what I said before about being motivated, being willing to learn, never stop learning. The day you feel comfortable and the day you feel like you stopped learning is the day that you're going to fall behind everybody else. The design software that we use is ever changing. Means and methods of construction are changing constantly. So you have to be open to adjusting and to changing with the times and really progressing along with those.
Awesome. Well, thank you so much for taking the time to talk to me today. And if anybody has any follow-up questions, my contact information will be shared right at the end of this video and can get them answered for you from Brian. Thanks again, Brian.
Thanks, Danielle.